Hello and welcome to a more relaxed post on physics. It's called The Center of the Universe. How you decide on the center of your coordinate system depends on whether you reason abductively or deductively. Abductive reasoning is like Occam's razor. You have a bunch of observations and you draw the simplest conclusion. But the history of science has shown us that Occam's razor inevitably fails because we can't observe everything. It was used to justify the geocentric solar system and the practice of bloodletting, after all. We often find that things are more complicated than initially assumed. Of course, sometimes we find that things are simpler than they seem. This was certainly the case with the Dunsmen, a group of pointy-hatted medieval scholars known for their labyrinthine logic and complex arguments. In a more modern example, the standard model of particle physics has been extensively tested based on a myopic form of abductive reasoning, and it tells us that time flows both forwards and backwards in equal measures, despite the fact that this conclusion contradicts all other measurements in existence. It is sort of funny when standard model physicists insist that this temporal inconsistency is more than just a mistake. In the world of billion-dollar particle colliders, there are no mistakes. There are only mysteries. That was abductive reasoning. Causal reasoning is a bit different. Causal explanation starts with Hume's definition of causation as a necessary connection. If A, then necessarily B. It implies no contradiction that B will always follow A. As in, this definition of causation implies no contradiction if one suggests that the sun might not rise tomorrow, or that a particle will fail to decay according to a precise schedule. Hume probably emphasized this point due to his connection to the church. Much of absolutist moral doctrine rests on the idea that the world could end at any time. Such a doctrine opposes the relative morality of those who believe that the ends justify the means, because if the world ends tomorrow, then there are no ends and no justification. In terms of modern physics, quantum mechanics is consistent with Hume's deductive definition of causation. There are causes which can fail of their effects because we are surrounded by random fluctuations of the quantum vacuum, which we cannot directly measure. As far as we know, these random fluctuations could be affecting the sun and a distant star like Betelgeuse in roughly the same way, causing them to behave in somewhat synchronized fashions. I don't know why I just said that, it just sprang to mind. Please ignore that statement, that's just one of my crazy thoughts. It is instructive to look at how one reasons abductively and deductively that the Earth orbits the sun and not the other way around. Abductive reasoning. Things fall when you throw them, and the sun travels across the sky as though it has been thrown. But at the same time, strange, wandering stars in the night sky can be mapped onto elliptical trajectories if one assumes that they, along with us, orbit around the sun. Otherwise, their trajectories are too complicated to understand. The simplest explanation is that we orbit the sun. This was abductive reasoning. Deductive reasoning says, there is always something which sets things in motion, and the sun and planets have always moved in repeatable ways, which can be modeled most accurately by Kepler's equations, in which a force called gravity governs their motions. Therefore, their motions are caused by gravity and a prime mover. There is a necessary connection between a prime mover, gravity, and elliptical motion. I find this all very comforting. It's this sense of, it's always been like this, you know? People have always been terrified by the fact that they're on a planet or a rock hurtling through the sky, and they're always thinking the world's going to end. Hasn't ended it didn't end in the past, so why should it end today? Standard model physicists have hacked together an equation of motion that will tell you what particles of different sizes tend to do as they shoot through a magnetic field. It's an extremely ugly theory, and if you click on the link to the blog post, you can take a look at it. But reverse engineering isn't usually pretty. There are a ton of different types of particles, and they all have their own little quirks like color and charm, in an abstract sense, of course. It would be nice if we could strip away the abstraction and describe these quirky objects as examples of something more basic. That is what brains and string theorists are doing. But I prefer bubbles, because so many systems can be described with bubbles, and wouldn't it be nice if you just had one theory for everything from cells to particles? It would make science so much simpler. What do big spinning bubbles tend to do in the vicinity of small bubbles, and vice versa? How do large collections of bubbles behave? In accelerator physics, electrons act a lot like bubbles. So you imagine bubbles rising through a column of liquid. The physics is the same as a beam of particles accelerated through a cavity. I found an old article from a woman, a Soviet physicist, who wrote a nice analytic theory of the interaction of gas bubbles in a sound field in 1984. And it was comforting how similar it was to our theories of atoms or our theories of planets. Just that there's a sort of unifying principle there. Wouldn't it be funny if the thousands of men working on the standard model were merely running in circles and giving each other awards for decades, while the correct theory was written about bubbles by a non-famous woman back in the 1980s? I don't think this is really what happened, but it would be funny if that were the case. If I try to understand gravity in terms of bubbles, I start with the simple question, does gravity push or pull? I conclude that starting point for any theory of everything should be that rotational motion within matter pushes out with v squared over r, while the quantum vacuum pushes in with 1 over r cubed. And if you put those things together, you get 1 over r squared gravitational force or electrostatic force. It's just bubble physics. If a bubble is moving fast, it gets squished in its direction of travel, and this slows down its rotation or its clock. That's time dilation. There is a maximum speed at which a bubble can travel, and large objects are heavy because the bubbles, or fundamental particles, within them are already moving at close to the speed of light. This is the cause of inertia. Makes things so simple. An alternative perspective, which is clearly communicated by a woman I saw on Quora named Jen Jameson. She promotes a description of how gravity and other fundamental forces arise from an accelerating expansion of space. And I like this perspective, but I prefer to think of the fundamental forces as coming from a vibration of bubbles within a liquid-like medium. And I don't think that there is a fundamental conflict between these two different sounding concepts, because when a building sinks into sandy ground during an earthquake, the space acts like it is expanding around the building. But this is only because the grains of sand are vibrating. The expansion is an illusion caused by the vibration of bubbles. This discrepancy in heuristics is the reason why astronomical measurements of the accelerating expansion of space are controversial and confusing for so many people. Some see an accelerating expansion of space in a Big Bang universe, and some see static space and light that loses energy as it travels over vast distances in a tired light or steady-state universe. The difference is a consequence of heuristics, conventions, definitions, coordinate systems, and perspective. If the universe is static, then everything in it is vibrating or circulating in a coherent manner. If the universe is expanding, then there is no coherent circulatory motion driving all of the fundamental forces. In terms of abductive and deductive reasoning, the accelerating expansion of the universe is the simplest explanation, given the known facts, like Occam's razor, whereas the static, vibrating universe is explained in terms of a necessary connection. The Standard Model and Big Bang universe is therefore an abductive theory, whereas the steady-state, tired light universe is a deductive theory. We often choose between theories based on aesthetics and ease of use, and today people tend to prefer abductive theories, They prefer the abductive theories in modern physics and the deductive theories in classical physics. This confuses everyone. On purpose? One consequence of this discrepancy is confusion. On the scale of fundamental particles, abductive collider physicists can detect no difference between time flowing forwards or backwards, but we certainly deductively experience time flowing forwards on the macro scale. Maybe from a more absolute deductive perspective, time is not flowing forwards or backwards. It only appears to flow forwards because our brains can only remember backwards. Maybe it is flowing in loops, and every time we make a decision which breaks us out of a loop, we change a largely static yet multidimensional picture. This is the sort of nonsense that pop scientists like to spread when they say, time is an illusion, but they just want to sell books. I think this is silly because if you got caught up in a negative entropy, I skipped ahead. Okay. A static yet multidimensional picture of where time is an illusion. This confusing result occurs when one mixes time together with space, or when the center of the coordinate system is moving around, as in quantum mechanics. Our minds are continually attempting to identify patterns in our memories. They are also attempting to predict the patterns of the future, and we think of our memories as being more reliable than our predictions. The asymmetry between these different levels of reliability is correlated with positive entropy. But if you got caught up in a negative entropy system in which your mind was getting stimulated with regular pulses of energy, like a microwave or something, you might end up finding that your predictions become more reliable than your memories. You might make a great fortune teller. In more colloquial terms, to demonstrate the absurdity of this picture, imagine a person getting bonked on the head with a baseball bat over and over again. Their prediction that they are going to continue to get walloped may be more accurate than their memories of the time before the walloping began. At this point, I should sort out how these concepts fit into the abductive and deductive framework, and how this explains why it seems that we sit at the center of the universe from a certain perspective. But I'm just confusing myself at this point and should probably stop. Going further would lead me to some shocking statements about the cosmic microwave background being both the warmth radiated by the stars in a tired light universe and being the quantum vacuum written large across the sky as a result of our motion relative to an absolute reference frame. I have a strange sense of humor about physics, and I'm trying to finish a couple of books on these topics. And in the meantime, please take a look at my fiction. It has a rather playful attitude about physics. Until next time, thank you for watching.